Here is an example of calculating volume of revolution using disk method. So we are given the blue function, y is equal to x squared, and axis of rotation, red, y is equal to 1. And we're supposed to rotate the yellow region in between blue and red, the region in between given function, blue parabola, and red axis of rotation. As a result of such a rotation of this yellow area around the axis of rotation, y is equal to 1, a 3D object will be created. The challenge is to calculate area of this object, of this volume of revolution. Okay, so we're going to follow the disk method procedure. Let's focus on just one slice. Let's cut this volume vertically with a sharp knife, imaginary knife. We're going to get a circular section, a slice, okay? And the first question might be, what is the radius of this slice? The radius, let's make it green. The green radius is equal to the distance in between blue and red. Okay, so the radius is equal to the difference, the blue minus red. The blue distance from x-axis to the top, the red distance from x-axis to the red level. So the difference will be equal to, will give us the radius. So the green is equal to blue minus red. What's blue? That's parabola, x squared. What's red? That's y is equal to 1. So this is our radius. Then the next question, what's the area? Now we can answer this question. The area of a circle, that's pi r squared. Okay, let's plug in. What is r? It's green. Let's plug in the value. So the area is equal to pi times x squared minus 1 squared. Okay? Next question, according to the disk method. We're going to consider this slice in 3D space. This slice has area, but also it has some thickness, dx, a small distance along horizontal direction, dx, change in x. So area of this slice times thickness will give us volume of this slice. So the volume, what's the volume of the slice? Just one slice. It is equal to area times dx. And then the integral sign stands for summation. We're going to add up all the volumes of all the slices along the given interval. The given interval, what's the interval? From 0 to 2, it's given. From 0 to 2. Okay? So let's plug in this expression for the area of the slice into the integral. Plug in. Let's figure out the limits of integration. We did it already from 0 to 2. And let's simplify. We can use, well, what we can do, we can factor out pi out of the integral sign. It's a constant. And then we can use algebra to extend the parentheses squared expression. Okay, now we are ready to integrate. We have to integrate 3 terms, and all of them might be considered as power functions. So it's easy to integrate an integral out of x to the 4th, x to the 5th divided by 5, integral out of 2x squared, that's 2/3 x cubed. Integral out of 1, that is just x. Okay, we're done with the integration. We still need to keep limits of integration. And we still need to apply fundamental theorem of calculus, which simply means we need to plug in the limits of integration. Plug in upper limit, then subtract the value of the same expression when x is equal to the lower limit. Let's plug in the limits. Plug in the upper limit, x to the 5th power. Ooh, x cubed, that's 8. X squared, that's 4. 8 times 4, 32. X cubed, 2 cubed, that's 8. Okay, so we did finish the integration. And what? If that would be a homework, then you use calculator. Otherwise, on the paper test, I would give you 100% credit. So this is, to be serious, this is one more step for your calculator, but otherwise we have solved this problem. We calculated volume of revolution using disk method. What is disk? This is the slice, one slice, which has area and some thickness, dx. Okay, and we calculate area of the slice, radius first, and then area, and then volume of one slice. Then we add up, integrate, add up all the slices, all the volumes by integrating along the independent variable in the given interval from 0 to 2 in this case. That was an example of calculating volume or volumes of revolution using disk method.